Hi, and welcome back. In our fourth part of this six-part series of factoring polynomials, we're going to be going back to trinomial factoring, but in this case, we're going to be looking at factoring trinomials of the type ax squared plus bx plus c. Now, in this particular form, what you'll notice is that the leading coefficient in this case is something other than 1. In the last video, we looked at how to factor out the trinomials where the leading coefficient was equal to 1, and the process was pretty straightforward. But now when the leading coefficient is something other than 1, things get a little bit more complicated, and so we have to approach this in a completely different way, or a slightly different way. There are two methods that we're going to look at here. One is called trial and error, and one is known as the AC method. But let's get into these right now. These types of trinomials involve a leading coefficient of something other than 1. Now, the first method that we're going to look at is the method known as trial and error, or guess and check, or try something and hope it works. Now, that's actually what we do. Now, we're not making random guesses here. What we're trying to do is make educated guesses about what the factored form is going to be, and then from those educated guesses, try to throw some numbers around and see if we can get something that's going to work for us that will actually be the factored form. Now, in order to get some insight as to how to make educated guesses, we need to know sort of how the multiplication works, because what we're doing, remember, when we're factoring, we're taking a trinomial or a polynomial and we're writing it as a product. So we're doing the multiplication in reverse. When we factor trinomials, typically, they're going to factor as a product of binomials. If you remember how to multiply binomials, we use what's commonly known as the FOIL method. FOIL meaning for first, outer, inner, and last. So for an example here, we have 4x plus 1 times 2x plus 3. So when we multiply this out, we take 4x times 2x, that gives us 8x squared. We multiply the first term in each of the binomials. Then we take 4x times 3. Those are the outer terms, so that gives us 12x. Then we take the inner terms, 1 times 2x, which is going to be equal to 2x. And then the last terms, 1 times 3, which is equal to 3. And so from this, we get the result of 8x squared plus 14x plus 3. Now, the one thing that I want you to notice here is that when we look at the process of doing the FOILing method, we can actually determine which terms come from what parts of the binomials we multiply together. So we know that 8x squared came from multiplying the first terms of each of the binomials. So that tells us that the first term of each of the binomials in the factored form has to multiply to give us the first term, or the squared term, in the trinomial. The last term, the constant term 3, came from multiplying the last terms in the two binomials, 1 times 3. So that lets us know that the last term in the trinomial is going to come from multiplying the last terms in the factored form, in the two binomials in the factored form. And the middle term, the 14x, this comes from the outer and the inner terms being combined together. Usually they'll be like terms that you can combine. So that's the OI, the OI. Using this knowledge, if we have a trinomial, we can make some good guesses as to where to place possible candidates for the terms in the binomials in the factored form. So let's take a look at an example and try to hash this out. So in this example, we have 2x squared plus 7x plus 6. We're assuming this is going to be a factored form, that this is factorable. 2x squared comes from multiplying the first two terms together. If we think about it a little bit, it looks like a couple ways we can get 2x squared. We could have 2x here and x here. 2x times x would give us 2x squared. The last term, which is 6, comes from multiplying the last terms in the binomials together. So for 6, you got a couple choices there. You could have 1 times 6, or you could have 2 times 3. So let's say we start with 1 and 6 and see if this works. Now, one thing that's missing here are the signs. Are we going to be adding or subtracting? We see that the last term, 6, is a positive number. So the only way that two numbers can multiply to give us a positive number would be if both the numbers are positive or both of the numbers are negative. Now in this case, both of the terms are going to have to be positive because notice that the middle term, 7x, we know that's going to come from the outer and the inner terms. So if they have to be the same sign and the middle term is positive, the only way you get a positive number by adding two numbers of the same sign would be if both of those numbers were positive. So that tells us that these are both going to have to be pluses here. So now let's multiply this out and see if it works. So if we FOIL this out, we'll have 2x times x, which is 2x squared. The outer terms, 2x times 6, that's going to be equal to 12x. The inner terms, 1 times x, that's equal to 1x. And the last terms, 1 times 6, that's equal to 6. So we have the first term and the last term. That's what we want. But now notice that if we combine the middle terms together, what happens? This gives us 2x squared plus 13x plus 6. All right, now unfortunately that's not going to work because our middle term was 7x. It wasn't 13x. So now that tells us that this is not going to be correct. So we got to try something else. What can we try here? Well, one thing we can do, with the first terms, we have to have 2x and x. So we know that's going to be the case. But now instead of 1 and 6, let's try 3 times 2 because 3 times 2 is equal to 6. So we'll put 3 here and at the 2 here. The signs are still going to be positive. All right, so now let's multiply this out and see what we get. First terms, 2x times x is 2x squared. The outer terms, 2x times 2, that's going to be equal to 4x. The inner terms, 3 and x, 3 times x is 3x. And the last terms, 3 times 2, that's equal to 6. So if we combine the middle terms here, 4x plus 3x, that is equal to 7x. So 2x squared plus 7x plus 6, that is the same as what we had originally. So that tells us that this 2x plus 3 times x plus 2 is going to be the factored form. Let's do one more example of this, a little bit more, let's make it a little bit more challenging. In this next problem, this next example, we have 6y squared minus 5y minus 6. All right, so once again, assume these are going to factor. And so we'll start with 6y squared. We can have 6 times 1 or we can have 2 times 3. So let's try 6 and 1. So I have 6y here and y here. And then for the last term, that's 6. Obviously, it's going to be 6 and 1. Now we could put 6 here and 1 here. We don't actually want that because if you notice the first binomial here, 6y and 6, they have a common factor of 6. If there's a common factor here, then that would imply that the original problem would have had a common factor for all the terms to begin with. So when we're breaking this up, one of the tricks here is that you don't want to break it up into a way that you have common factors within any of the parentheses or the binomials. So we'll put 1 here and we'll have 6 here. All right. Now the other thing, notice that the last term is negative. So now the way that we get a product of two numbers equaling to a negative number is if one's positive and one's negative. The signs have to be different. So in this case, one of these are going to be plus, one's going to be minus. Now it could be the other way. We don't know. We got to try it out, see if it works. All right, so we have this guess. Let's FOIL it out, see if it works. So 6y times y is 6y squared. The outer term, 6y times negative 6 is negative 36y. The inner terms, 1 times y is equal to 1y, or just y. And then the last terms, positive 1 times negative 6 is negative 6. So that's going to give us 6y squared minus 35y minus 6. All right, so obviously that's not going to give us, with that middle term, negative 35, that's not what we have for the middle term here. So this is not going to work. We need to try something else. So how about with the instead of 6 and 1, we try 2 and 3. We'll get 6y squared. The outer terms, 2y times negative 6 is negative 12y. The inner term, 1 times 3y, that's equal to positive 3y. And then 1 times negative 6 is negative 6. Okay, we see this is not going to work here either, because if we take a look, if we combine those middle terms, that's going to be negative 9y y. That's not the same as what we had before, negative 5y. So this is not going to work as well. Now, in retrospect, this also wouldn't have worked because notice in that second factor, 3y minus 6, there's a common factor of 3. And as I mentioned before, if there's a common factor in any of the ways that we guessed this out, it would have to be a common factor in the original problem. And there was no common factor in the original, so that wouldn't work either. Let's try something else. So I'm going to stick with the 2 and the 3 for the y's, but now I'm going to try 2y plus 3 and 3y minus 2. So I'll go 3 and 2 with the last terms. All right, so now if we FOIL this out, let's see what we get. We get 6y squared, the outer term, minus 4y, the inner terms, plus 9y, the last term, minus 6. So now here, oh, we're close. If you combine the middle terms here, negative 4y plus 9y is equal to positive 5y. Okay, but we have negative 5y. Now, the nice thing about that is that if the only mistake you have in the middle term is the sign, then that just lets you know that we just need to switch our signs. We have, let's do 2y minus 3 times 3y plus 2. FOIL that out, 6y squared, 2y times 2 is positive 4y, negative 3 times 3y is negative 9y, negative 3 times 2 is negative 6. The middle terms give us exactly what we want, negative 5y. And so that lets us know that this is going to be the factored form. One thing that we can see here is that the guess and check method, in the first case, we were able to get it correct in the first couple of tries. The second problem here, it took us 3 or 4 tries to get the correct answer. This kind of gets into some of the pros and cons of this particular method. One benefit of this is that it can be really quick if you happen to guess the answer correctly in the first couple of tries. However, the downside, it can be challenging though if it requires you to go through a few tries before you get the correct answer. And this can happen if your coefficients or your constant terms have many factors. So like for example, here with 6, you had like 6 times 1 and 3 times 2, and we had to kind of fiddle around with that and then work with the signs to get it to work out. One of the worst cons or drawbacks of this particular method is what happens if it's not factorable, because that's entirely possible. With the guess and check method, the only way that you can determine that it's not factorable is by going through each and every single possible combination of numbers and making sure that none of them work. That can be somewhat difficult if you have a case where you have multiple factors and you try a number of different ways, because how do you know that you've exhausted all the possibilities? How do you know there might be some possibility that you hadn't thought of? So that's kind of one drawback here, is that if it's not factorable, you have to go through every single possible combination to make sure it doesn't work. So to that end, what we're going to look at is a second way of factoring the trinomials, which is known as the AC method. Some textbooks actually refer to this as a grouping method, which seems a little bit counterintuitive because with the grouping method usually involves factoring 4 terms. But now this particular method does actually involve the use of grouping. And so the objective with this method is to actually take that middle term, break it up into 2 separate terms so that we can then factor by using the grouping method. Let's take a look at an example and we'll walk through the steps that are required in order for us to factor using this method. So for the AC method, I'm actually going to start by looking at the same 2 examples that we started off with before when we used guess and check. So we have a chance to sort of compare the 2 methods apples to apples. Okay, so if you recall our first example, 2x squared plus 7x plus 6, we already know what the answer is, but now we're going to look at this using this AC method or grouping method. The first thing that we want to do, first step, is to find 2 numbers whose product is equal to the leading coefficient multiplied by the constant term. Okay, so a times c. So now remember that the trinomial is ax squared plus bx plus c. So a represents the leading coefficient and c represents the constant term. And you want the same two numbers to have a sum that's equal to the linear coefficient, the coefficient of x. Now, you hear that, and that may sound a little bit familiar. And that is very similar to the method of factoring the trinomials when the leading coefficient is equal to 1. But there is a significant difference because in that case, the product was just equal to the constant term. But in this case, the product is equal to the leading coefficient times the constant term. So there's a difference there. So in this case, we want to find two numbers whose product, in this case, would be equal to 2 times 6, or 12, and whose sum is equal to the linear coefficient, which is 7. Well, in this case, those two numbers would be 3 and 4. 3 times 4 gives us 12. 3 plus 4 gives us 7. What we're going to do is break up the middle term. So the middle term, 7x, we're going to write that as a sum of terms using those two numbers. So we'll bring down the 2x squared, and then we'll have 3x plus 4x. All right, so you see what I did there. I broke up the 7x into 3x plus 4x. So I use those two numbers to break up that middle term. Then we pair off the terms. We look for the common factor in each pair. So the first pair of terms has a common factor of x. Bring down the plus. In the second pair, the common factor is 2. And when we factor that out, we have 2x plus 3. And so now both of these groups have 2x plus 3 in common. So we can remove that common factor, 2x plus 3. And what's left over? X plus 2, which, if you recall, is exactly the result that we got when we did trial and error. All right, so you can see how this method is a little bit more technical. It's more methodical. It's not as random. So now let's take a look at the other example that we did. We want to find two numbers whose product is equal to a times c. So in this case, a is 6, c is negative 6. So we need two numbers whose product is equal to negative 36 and whose sum is equal to the linear coefficient, which in this case is negative 5. So now what two numbers would have a product of negative 36 and a sum of negative 5? In this case, the two numbers would be positive 4 and negative 9. 4 times negative 9 gives us negative 36. 4 plus negative 9 gives us negative 5. And so those are going to be the two numbers. And so we take the two numbers, break up the middle term using those two numbers. So here we'll have 6y squared plus 4y minus 9y. And oh, by the way, it doesn't matter what order we use with those two numbers. We could have put the negative 9y first and then the 4y. It'll still work out. So then, once again, pair off the terms. First two terms have a common factor of 2y. We factor that out. That'll give us 3y plus 2. Bring down the minus. The second pair have a common factor of 3. And since we're factoring out a negative 3, we're going to change the signs. So we factor this out. This will be positive 3y plus 2. We've got those common factors of 3y plus 2. So we end up with 3y plus 2 times 2y minus 3, which is the same answer that we got when we did the guess and check. Now this, we can see, obviously took us less time than going through all of the 4 guesses that we did to get it by trial and error. You can kind of see the benefits here of using the AC method because, once you find those two numbers, then you're just basically using a previous method of factoring, the grouping method, to work it out. So that has some convenience. Another point of convenience about this particular method is that it actually takes out some of the guesswork. Because remember what I told you about the guess and check method, how you'd have to go through all of the different possibilities before you could draw the conclusion that the trinomial is not factorable. Well, in this case, you can determine that it's not factorable before you go too far into it. Because when you try to find those two numbers, if the two numbers that you're looking for, whose product is equal to AC and whose sum is equal to B, if those two numbers don't exist, then the trinomial is automatically prime. So that eliminates a lot of the guesswork. So if you don't find the two numbers you're looking for, or if those two numbers don't exist, I should say, if the two numbers don't exist, then the trinomial is prime and you're done. So that's one benefit of this particular method. So now let's take a look and do one more example. So with this example, we have 8x squared minus 14xy plus 3y squared. So in this case, we want two numbers whose product is going to be equal to 8 times 3, which is equal to 24, and whose sum is equal to the middle coefficient, negative 14. Now here, since the sum is negative, but the product is positive, this tells us that the two numbers that we're looking for will both have to be negative. And in this case, that's going to be true because the two numbers that would fit here would be negative 2 and negative 12. So we see that the two numbers here would work because negative 2 times negative 12 is equal to positive 24, and negative 2 plus negative 12 gives us negative 14. So then what do we do next? The middle term, break that up. We have 8x squared minus 2xy minus 12xy plus 3y squared, and then factor by grouping. So the first pair of terms, common factor here is going to be 2x. Extract that, we'll have 4x minus y, and bring down the negative. The second pair of terms has a common factor of 3y, and so when we factor that out, we'll have 4x minus y. Remember, we're factoring out a negative, so we have to change the signs. So both of those have 4x minus y. Factor that out. What's left over is 2x minus 3y. And there we have the factored form. Now, one of the nice things about about factoring in general, is that you can always check your answers to see if you've done them correctly by simply multiplying them out. If you multiply it out and you end up with the original problem, then you know that you factored it correctly. All right, so you can always use that as a means to check your work. I am more of a fan of using the AC method than I am using guess and check. Now, the more practice that you get with practicing these types of trinomials, the better off you'll be. This is one of those things where it's going to be beneficial to get the practice. The more you practice it, the more you'll begin to see some patterns in the multiplication and in the factoring out that will enable you and empower you to factor these things a little bit more quickly. One thing that I've found is that by practicing the AC method and doing it over and over again, it helped me to be a little bit better at doing trial and error. So the methods can kind of help each other out. But once again, I want to stress that for this particular type of trinomial, it can be tricky because of that leading term being something other than 1. And practice is going to be the key. The more of these problems that you do, the more familiar you become with them, and the easier it will be for you in the long run. So I do strongly encourage you to get practice. You could probably you have your homework from your textbooks. If you're doing this in school, you can go online and just say factoring practice worksheets. Just do a Google search for that, and you'll find all types of resources that'll help you to get more practice with these. Trust me, you practice them, you'll get it. You can do it. That's all I have for you for this video. And so I hope this was helpful. Be sure to give the video a like, subscribe if you like this video. If you have any suggestions on videos or topics that you'd like me to cover for future videos, just put it in the comments section and I'll try to get to it as quickly as I can. So you guys have a good day.